So now we're going to continue looking at libraries, and what we're going to look at today is going to be the math library. So the math library contains a lot of great math functions that we can use to do more complicated kind of math operations. So I'll just show you some of the ones that they have today, and I'll also show you some of the limitations. And then later on, we'll be introducing other packages that may kind of make up for these limitations, or kind of play on these and expand on them, and kind of remove the limitations that are contained inside the math package. But nevertheless, the math package is very, very good, especially for everyday use. So yeah, let's take a look at that. So what we're going to do is we're going to import, and to import the math package or the math library, we're just going to import math. And we're not going to import it as anything special. We're not going to import anything special from it. We'll just import the whole package. So we don't really have any memory constraints right now. All right. So what are the things that we can do with the math package? Well, the first thing that we can do, for example, is take the square root. So let's just create a general variable. That's going to be our val. So it's going to be our value. And let's just have it be equal to, and let's just put in a random number. So let's just put in 3. So what we're going to do is we're just going to kind of do different operations on this value. So we're always going to use the same value, but we'll do different math operations on it, just because we can. All right, so the first thing that we want to do is we want to take the square root. So we'll save it in a variable called square root, or we'll go short for square root of val. So square root of val, and that's going to be equal to, and now we want to take the square root of this. So what we're going to do is we're going to go into math, and then we use the dot to go into it. And now what we're going to do is we're going to go into square root, SQRT, so that's short for square root. And what we're going to do is we're going to take the square root of the value, which is 3. And then if we print out the square root of the value like this, and if we run our code, then we can see that we've now gotten the square root of 3. So to check that it really is the square root, we can also square it again. So we remember that to square, or to do a power operation in Python, we can do multiply, multiply. And then we can put in the number that we want to take to the power 2. So in this case, we'll do multiply, multiply 2. And what this is in this essence is this is square root of val to the power of 2, just like this. So technically we can also put brackets around this, but we don't really need that. So just to make sure that our square val is actually the square root, let's just square it, and we see, well, we get pretty close to 3. So this is one of those kind of limitations, but this is also a lot due to rounding errors. So your computer is dealing with, it only deals with finite numbers, and so at some points it has to cut off and round. And so if we square this, we actually don't get the full 3 value back. That's because the square kind of continues on here. And so this is one of those kind of limitations that we see, is that we get these rounding errors. But this is pretty good to, we're pretty close to 3. So that's still pretty good. So the square value is a very good approximation of the square root of 3. So yeah, maybe we just take this out again, and just leave it as a square root value. So the next thing that we can do, for example, that's also very useful, is we can take an exponential. So not just 10 to the power, but we can also do e to the power, for example. So e is kind of Euler's constant. So if we do the exponential of the value, we can do equals to math. And then here we want to take the exp. And then we can just do the exponential of the value. And so what this is going to do, this is going to be e to the power of the value, like this. And e is Euler's kind of constant. So we can print out the exponential value, and we'll see first we get the square root, and then we get e to the power of the value. So this is how we can do the exponential, for example. Another cool thing that we can do is take the factorial. So we can maybe create a variable called fact val, so this stands for factorial. So if you don't know what factorial is, it's pretty much 3 factorial, and so this exclamation mark is actually the sign for factorial. That's equal to 3 times 2 times 1. So it's pretty much equal to this number multiplied by all of its lower integers until you reach 1. So if it was 5, for example, it would be 5 times 4 times, times 3, and then times 2 times 1. So that's 5 factorial, for example. So we can take the factorial of our value too. So we can go factval is equal to, and then we go into math dot factorial like this. And inside here, we'll just put in our value again. And then let's just print out our factorial value on the next line, like this. And if we run our code, we see that we get the square root, we get the power, and then we can actually calculate the factorial ourselves. So 3 times 2 times 1, 3 times 2 is 6, times 1 is 6, so we see we get 6 here for the factorial. Yeah, so these are kind of these basic functions. Another thing that we could do, for example, is take the sign. So sign of the val is equal to, and then we go into math dot, and then sign, and then we open and close parentheses, and now we can put in the value. And so something that's important to note also is that these sine functions and the cosine and the tan and what else not, it's all in radians. So if you're dealing in degrees right now, you may want to convert to radians first, or else you're going to get surprising results. So if we run it, oh, we didn't print it out, so we're not seeing anything. So let's print out the sine val. And so if we run our code, we see we get a value of, well, close to 0. So yeah, I mean, we're looking at the value of 3, which is very close to pi, so 3.14, and the sine of pi is 0, so we expect a value close to 0. So if we make this 3.14, for example, which is even closer to pi, okay, well, factorial, so this is one of those things that factorial only accepts integers. And maybe we can actually move on to the next thing that we're going to look at anyway, and that's going to be the math ceiling and floor. So what that does is it rounds to the highest or lowest integer number, kind of accordingly. So anything that's less than or equal to. So for example, if we just comment this out here for a second, and this, and then we can uncomment it in a second again to use it, but let's say floor val is equal to, and then we go into math dot floor, and then we put in the value here. What we're getting is we're going to get this rounded down to the lowest integer, to the nearest lowest integer number. So if we print out floor val, for example, then what we're going to see is we're going to see 3. And well, here we see the thing for pi, so it's getting even closer to 0. Well, not really pi, but very close to pi, so it's getting even closer to 0. And so what this floor val does is it rounds it down to the lower integer. So if it's not complete, it just kind of rounds it down back to 3. So even if we make this a 9, for example, we see that we still get 3 here. So it kind of cuts away the decimals and it rounds it down. Something else that we can do, though, kind of the opposite of the floor, is something called a ceiling. So we can do ceiling val is equal to math, and then to go inside the math, we use the dot again. And now here we're going to use the ceil function, and then we'll do it on their value. And if we print this out, so let's print out our ceiling value, ceiling val. And so what this ceiling function does is the opposite of this floor function. It's going to round it up to the next integer. So in this case, it will round it up to 4. So if we run our code now, we'll see we get 3 from the floor. So that means we're rounding this value down to the nearest integer. And we get 4 from the ceiling. So that means we're rounding it up to the nearest integer. So these are also two kind of really, really cool functions that you can deal with. Because generally, if you just round or if you just convert, if you just round, It depends on what decimal place you are. If you just convert, it could be that you just cut off the decimal places. So using these floor and these ceiling functions really define what you're doing with the number, and it really tells you how to convert. So that's very useful too, and we can really make use of that in here, for example. So here we need to take an integer value in, or else it doesn't work. So what we can do is we can make this an integer by doing a math.floor, for example. So we're going to round this down to the nearest integer. So what we're going to do is we're going to round 3.14 down, which rounds it to 3. So if we run our code, now we see we get this number here for the square root. We get this number here for taking e to the power of 3.14. We get 6 because we've rounded down 3.14 to 3, and then we did the factorial, so 3 times 2 times 1 is 6. Then we calculated the sign, which is very close to pi here, and so we get a number very close to 0 here because the sign of pi is 0. Here we've taken the floor value, which gives us 3. Here we've taken the ceiling, which gives us 4.